Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope everyone is doing all right out there. I don't know what the title is going to be for this. It depends on what your class is. But what I do know is what the goals are. And we have two goals today. Our first goal is to discuss how we measure and classify angles. And our second goal is to introduce the angle addition postulate and see how to use it. Alright, so our first goal. Which is the larger angle? I use this symbol for angle. Which is the largest angle and why? Angle ABC, ABC, remember vertex in the middle? Or angle DFE, DFE. Which is the largest angle? Angles are measured by how much they open, and the unit of measure is in degrees. A small circle at the top of the right side of the number indicates a measurement in degrees. An example, if I see this, it literally translates to 35 degrees. This is not a zero exponent. It means that I've measured an angle. I've measured how much something opens. Okay? So back to our original question. Which of the two angles is larger? And seeing that how our angles are measured, the more it opens, that means that angle ABC is larger. So angle ABC is larger because it opens more. All right, so I'm going to go ahead and erase everything. I'm going to talk about the tool we use to measure angles and how we classify the angles. So let me erase this and I'll be back. I'm back to continue the first goal. So let's jump right in here. So I'm going to talk about how we measure angles, and we measure angles using a tool called a protractor. So this is my attempt to draw this. I don't know how good I did. I think I did well for me, but this is my attempt to draw a protractor. So the way a protractor works is you set it on top of the angle. Now notice there's two sets of numbers. An interior set of numbers that starts at 0 and goes to 180 degrees, and an exterior set of numbers that starts with 0 over here and also goes to 180 degrees. So the way that you measure an angle, or how much it opens, is you place the protractor on top of the angle so that a side of the angle lines up with a 0 here or a 0 there. You want the vertex to go there, and then you just see where the other side of the angle goes, right? So we would call this a 70-degree angle because it starts at 0 here, right? So this would be an example of a 70-degree angle. Now, if I was to measure an angle that had its side coming off this way and it went up this way, we would call that angle 110 degrees because it starts at 0 over here and it opens up 110 degrees. So hopefully that clarifies how to measure these. It's going to be a little difficult this year to teach using these because we don't have these in our hands, and I can't guarantee that everybody has access to a protractor, but that's how a protractor works. It measures angles. Now, we classify the 4 types of angles by how much they open. An acute angle measures between, or opens between, 0 degrees and 90 degrees. Between, not at 0 to 90, but between 0 and 90. Okay? Those are our little angles. Oh, you're so acute. A right angle opens up or measures exactly 90 degrees. This little square, that's the symbol for a right angle. Okay, so if it opens less than a right angle, it must be acute. If it opens more than a right angle, but not to 180 degrees, we call that an obtuse angle. It opens more than a right angle, but less than a straight angle. A straight angle measures exactly 180 degrees. Now, I'm going to share this with you. I was watching a movie once, and somebody said, well, that idea is obtuse. And the character he said that to got very upset. And I didn't know that you can call something dumb by calling it obtuse, because obtuse angles are not very sharp like acute angles. And if somebody is really good at something, they have an acute sense of smell, they have a sharp sense of smell, so it's good. So a way that people used to insult each other was say, that was obtuse. Don't go around insulting people. But if they call you obtuse, put your hands on your hips and say, I don't appreciate that. So I'm going to go ahead and end this right here. I'm going to come back and introduce the angle addition postulate and how we use that. So let me clean up this whiteboard and I'll be back. I'm back. Now, I have to apologize. I forgot to include something in our goals, and we'll call it our 1.5 goal. I'm not sure if there's a RD or an ND, or I'll just put a CH, but our 1.5 goal. I forgot to put a goal between these guys. And the goal that I want to talk about is what it means to be a congruent angle. And the mathematical description will be congruent angles are angles that have equal measure. I think the easier way to understand it would be congruent angles open the same amount. Remember, that's how we measure it. So if you think about measurement as opening, how much it opens, that'll hopefully make the concept a little bit more clear for you. I have an example of congruent angles. Now, just like with segments, we can put a symbol on a picture that tells us without saying that we have congruent angles. So these little red marks, we call these arcs. This is called a congruent arc, and it indicates congruent angles, okay? So you'll see that in a picture. It's a way that I can tell you something without saying it. Remember, I'm going to communicate to you without saying the exact concept. Now, this would be a congruent statement where we're talking about the object. Angle A is congruent to angle B, which again means same shape, equal size, right? So we have a congruent statement, and with a congruent statement we talk about the object, the shape. Now I can also say the measure of angle A is equal to the measure of angle B because they're congruent. Remember, congruent means they open the same amount, so that they have the same measurement. I have to use an equal sign when I talk about a measurement because that's a number, right? So we use this is an angle as a number. It's a little goofy to think about one object in two ways, but you have to do that in geometry. We can talk about the object or the way we measure the object. And when we talk about the way we measure the object, we can get into equations. So that segues into the second goal, which is the angle addition postulate. And the very mathematical way to introduce it is if a point is in the interior of angle ABC, then let me read this to you and then I'll translate it. The measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. So basically what they're saying is if I have a point that's inside the angle, in the interior, right? That's what it means to be inside. You're in the interior, right? Out here is the exterior, but this point is in the interior. If you have a point that's in the interior, then you can make another angle. And what this equation is saying in a very simple way is the amount that this little angle opens, angle ABD, how much this opens, plus how much angle DBC opens, how much this little angle opens and how much this little angle opens equals how much the large angle opens. So I hope that this makes a little bit more sense to you about what the angle addition postulate is. All right, now we're going to see equations in this. Maybe this small angle is, I don't know, x plus 2, and maybe the other small angle is x minus 5, and then we know that the large angle, and they'll put a mark like this, they'll say that this is equal to, oh, I don't know, 27. I'm making up a number, I don't know exactly if this will work out to be nice numbers. But what we would do is first write the angle addition postulate. So we get the measure of angle ABD plus the measure of angle DBC, and that equals the measure of angle ABC, right? The two small angles add up to the large angle. And again, this is a postulate because we accept it as true, right? You can't really argue that it's not true. You don't have to convince anyone. This one opens up an amount, and this one opens up an amount, and together they open up to the big amount. I think that's, you don't need to argue it. So now that we have our equation, I can substitute. So the measure of angle ABD turns into x plus 2. The measure of angle DBC turns into x minus 5. And the measure of angle ABC turns into, oh, I forgot my little circle, turns into 27 degrees. And then you solve. Right, you find the value of x, and you can then use that to find the measure of the angle by plugging it in, find the measure of this angle by plugging it in, and they both should add up to that. All right, so I'm going to go ahead and end the video here. I'd like to dedicate this lesson to Dr. Mary Stafford. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.